Algebra 1. This is a little mid-semester review since we have such an extended spring break. This is information that you would want to know for later in the semester for our final exam. And also it's just kind of some stuff to keep your brain working over these next 2 weeks so that when we do return to school, you are, already in the math mind of how to do some things. So we're just going to do a brief review of each unit that we've done so far this semester. So Unit 6, the problem we're going to do is graph and shading the system of inequalities. I want you to notice that y is already solved for both of these inequalities, which is good. That means we can go straight to graphing. So our first inequality has a y-intercept at 3, 0, 3. That'll be up on our y-axis. And our slope, which is m, is -2. That tells me to go down 2 and right 1. So you can go ahead and you can just watch this video since you don't have the sheet for this, or you can print it off of Canvas. I did put a blank version on Canvas. Okay, and then since we have an equal to, this line will be solid. And it is a greater than. So since it's a greater than, we will be shading up, which up in this case is really on the right. Okay, you get the point. Alright, our next one, we have a y-intercept at +5, 0, 5, and a slope of 1/2. So I will be going up 1 and right 2. And this will be a dotted line because we don't have the equal to. And it is a less than symbol, so I will be shading down, which means this bright blue part is going to be our what we call feasible region. Okay, so it should just be this whole region there. All right, go ahead and take a second and shade that. And we'll move on to Unit 7. So Unit 7, we were dealing with exponents and also exponential growth and decay. So in this situation, we have the cost of manufacturing a computer has decreased by about the same percentage each year. The cost C in dollars in year T can be modeled by this equation right here. So the first question we have is this the situation growth or decay? This would be decay, because that number right there in parentheses is less than 1. Now, your rate as a percent is tricky. This is hard to do when you have decay. We're going to take our 0.91, we're going to subtract it from 1. And that gives us a 0.09. And then the 0.09 we will convert to a percent. So we can do that by timesing by 100 or moving your decimal 2 places to the right, and that will give you 9%. What is the cost of the computer after 5 years? Years is a time, so I'll just take this 5 and I will plug it into my t value, and this is something I will do with my calculator. So we'll type it in. And this is money, right? This is a cost, so we'll round to the nearest hundredth. So $499 and it looks like 23 cents because our 5 will push our 2 up. Alright, so next we're going to look at simplifying with some laws of exponents. So we had all these different rules that we could do with exponents. Let's see if you remember them. First, for number 3 here, we should divide our 10 and 2 because those are just regular numbers. 10 divided by 2 is 5. And then if you look at your x's, they're both positive exponents, but they're on different levels. Our rule for that, we will subtract them. 10 minus 4 is 6, and since the 10 is bigger, we'll put that x to the 6th on the bottom. So I guess I didn't need that fraction bar quite so big. There you go. This guy right here, we have multiplication going on in here, and because of that I can distribute my exponent. Please be careful, this is a negative 3 to the second power. Notice how I have parentheses, but for all of my exponents I will go ahead and multiply those. So this will be x to the 4th, 2 times 2, and y to the 10th, 5 times 2. Then I'll need to evaluate negative 3 squared. This is just the same as 3 squared, even though there's a negative, it's in parentheses, so it will be a 9. Number 5, so this one we have a lot of negative exponents. So when we have negative exponents, what we're going to go ahead and do is move them. So everything down here, it's negative, it's going to move up to the top, and then this g with the negative 12, it's going to move down to the bottom. The m to the 5th is going to stay exactly where it is. So basically I'm going to flip-flop everything except for that m. Once I move everything, notice how my exponents are now positive. Okay, now there's one last step, and that's because we have a g on the top and the bottom. So we'll go ahead and do the same thing that we did with our x's here. We will subtract them, but notice this time the bigger number is on top. So when we subtract, we will put our g to the 3rd on the top as well. Okay. All right, number 6. This time we're multiplying, so we'll multiply our negative 2 and 5. X to the 0, that's just a 1, that cancels. So we only have x to the 13th left. And then your y's here, they're on the same level and they're positive, so this we will add. 18 plus 10 is 28. Alright, and that's your review of laws of exponents. Let's flip the page and move on to Unit 8. Unit 8 was a lot of graphing information. We're going to find the information based on the equation below. Graph and plot your vertex, zeros, and y-intercept. So the first thing, this is in standard form. Standard form, we need our calculator to identify the vertex. So what I'll do is I'll go to my y equals, and I will type this guy in. Go ahead and do so as well. And I'll graph, and the vertex is going to be down here, and we should notice this is going to be a min. So I'll go second trace min. Left bound, I'm going to move my vertex, or my cursor, excuse me, to the left. Okay, it's going to take a little bit to see. Oops, sorry, I'm going the wrong way. Let's try the other way. So my y's are getting smaller, so eventually I'll get there. Dun, 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 dun. Keep on going. Keep on going. There it is. Okay, so left bound, I'm on the left, I press enter. Right bound, I'm going to keep on going to the right. It's going to disappear for a minute. I'm going to come out the other side. There I am, enter. And then guess I'll go back in the middle, so I'll be kind of hidden here. Good enough, enter again. So that's going to be a 4.5 comma negative 12.5. And this would be a good time to draw my graph. Notice it doesn't look like there's a y-intercept, but there will be one up there. So when you draw your graph, you should draw it like it has one. We're going to find the y-intercept. The min we just found, that was, let's see, what was it again? 4.5 negative 12.5, so we'll label that here. And we'll put it here. And then the other dots I'm going to put are my zeros. Alright, here we go. Axis of symmetry. Axis of symmetry is the vertical line that cuts our parabola in half. It always is x equals because it's a vertical line, and x equals the 4.5, which is the x coordinate of the vertex. Orientation, this parabola is opening up. We also can tell because our a value is a positive. Shape, it is narrow. That's because we have a 2, which is more than 1. Y-intercept, here's how we find it. Second trace value, and x equals 0. You're not going to be able to see it, but it'll tell you where it is. It's all the way up at 0.28. You can go ahead and label that. All right, now for the zeros, we know they're on the x-axis. So it's really important you go back to your y equals. You do have to tell your calculator that you want to find the zeros by putting a 0 in y2. What that's going to do is graph my red line here, and now I can just find those zeros using my second trace 5, which is how I find any other intersection. Okay, so second trace 5, move your cursor over, enter, enter, enter. There's my first one at 2, 0. Label, and then I'll do this again, second trace 5, move my cursor over to the other intersection point. It's going to get there eventually. There it is. Enter, enter, enter. 7, 0. Again, really important that you have your y2 equals 0. Otherwise, you're going to do second trace 5 forever and nothing will happen. Okay. All right, that's your review of Unit 8. Unit 9, solve by taking the square root. So these are our types of problems that we need to remember are plus or minus. We'll start by getting the x squared by itself. So we'll divide by 2. And now that x squared is by itself, I can square root both sides. Square root of 9, that's a perfect square, plus or minus 3. Notice the root goes away because this is a perfect square. All right, number 9, I don't have to divide by anything, but I do have to subtract my 12 first. 200 minus 12 is 188. And now I'll go ahead and square root. And 188, as far as I know, is not a perfect square. Remember, if you're not sure what multiplies to 188, start with division. 188 divided by, I'm going to try divided by 4. 47 times 4. Okay, and 4 becomes 2 and 2. 47, I don't think a 47 breaks down at all, so it seems really weird, but 47 is actually going to get underlined. Our pairs are 2's, circle cross out. So we'll have x equals plus or minus 2 root 47. So that's it for that one. Okay. All right, one more like this. Let's add our 10. Negative 80 plus 10 is negative 70. Okay, we can't square root yet. We're going to need to divide by 5. Negative 70 divided by 5 is negative 14, but some of you may have already noticed we can't take the square root of a negative. So we call this no solution, or no real solution. All right, so next we're going to solve by using the quadratic formula. This problem is different from the one above because we have this b value, that 15x. When we do quad formula, we'll start by making sure we have an equal 0. We'll move everything to one side. So notice I'm adding my 50 over. This is when we identify our a's, b's, and c's. Your a value is going to be 1. Your b value is the 15, that's always with the x. Your c value is 50. And let me write your quad formula over here for you. It's x equals to opposite b plus or minus square root of b squared minus 4ac all over 2a. And remember this part here we call the discriminant, and it tells us how many solutions we're going to have. Okay, so if we get a negative, we know it's no solution. If we get a positive, we're going to have 2 solutions. And if we get a 0, we're going to have a 1 solution. Okay, so let's go ahead and let's plug it in. Opposite b will be negative 15, so x equals negative 15 plus or minus square root of b squared minus 4, the a value is 1, the c value is 50, all over 2a, so 2 times 1. Okay, now we'll evaluate the discriminant. So we can just type that in. and we get a 25. Two times 1 is 2. So notice we have a positive discriminant, 25, so that means that we'll have two answers here. So let's go ahead. We have negative 15 plus square root 25, enter. Don't forget to divide by 2. So first solution, x equals negative 5. Or now we do the other one, negative 15 minus square root 25, enter. Don't forget to divide by 2. So negative 10. So again, just a reminder about what that actually means. We have a parabola here, and what we just found were really the zeros. We have intersections at the x-axis at, whoops, that would be negative 10. Negative 10, 0, and negative 5, 0. Okay. And I know that it's going to look like this. It's facing up because look, your a value is a positive 1. So think about what we talked about with orientation and shape up here. This is the same thing. Okay. All right, last thing we're going to review is Unit 10. This is the stuff that we just started dealing with in our green packets. So first we will multiply. Remember, multiplying is FOIL. Now some of you might recognize our sum and difference pattern here. That means if you wanted, you could do first and last. I'm going to go ahead and do all of FOIL though. X times x is x squared, so that's first. Outer, x times negative 2, negative 2x. Inner, 2 times x. And last. Remember, you're multiplying. It's not 2 plus negative 2, it's 2 times negative 2. So that's negative 4. So the whole reason we could do first and last is you're going to notice your outer and inner here cancel. So it's really just x squared minus 4 is your answer. Cool. All right, last thing, factoring. Okay, so factoring, remember, are when we're multiplying to this number and adding to this number. So we're multiplying to 20 and adding to 12. It's basically the backwards FOIL, so backwards of what we just did. All right, so if you look, see how we're multiplying to a positive? That means your signs have to be the same, but we're also adding to a positive. So these are going to be two pluses. And the numbers that multiply to 20 and add to 12 are 10 and 2. So plus 10 plus 2. Okay. And if you FOILed that out, first, outer, inner, last, you would get this. Okay, let's try this one. X. Notice how I set this up. You're going to do that when you factor. So this one's a little different because there's no x value. This is like if there was a 0x. So we're really multiplying to negative 64 and adding to 0. That would be a positive 8 and a negative 8. Okay. All right, we'll try this one. So again, this is the most recent stuff that we've been doing. This one we're multiplying to 49 and we're adding to negative 14. Notice we're multiplying to a positive but adding to a negative. That means both of our signs have to be negative. Okay, so think multiplies to 49, adds to a 14. That's going to be 7 and 7. But again, both will be negative. You could also write it like this, since those negative 7s are the same. Hey, 3 more. We're going to multiply to 6. We're going to add to negative 7. So again, I'm multiplying to a positive. My signs have to be the same, but I'm adding to a negative. So that means both of these are negatives, and that's going to be 6 and 1. 6 plus 1 is 7. 6 times 1 is 6. But again, we have negatives here, so that's why we add to a negative 7. Same with this guy, multiplying to a positive, adding to a negative, so that will be 2 negatives once more. Did a lot of negatives here. So what multiplies to 27 and adds to negative 12? Multiply, add. That will be negative 9 and negative 3. All right, in our last review problem here, we are multiplying to 36 and we are adding to 12. And take a moment to think about those numbers. They will be 6 and 6, and since they're both positives, you could rewrite it like this as well if you would like. Okay, so there's a little review for you of everything, well, not everything, but a lot of things that we've done so far this semester, which should help to keep your skills sharp. I also posted a worksheet that you could do. So let's see, let's go to Canvas, let's log in. Dun, 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 dun. Okay, so if you found this video on Canvas, so you kind of already know what that looks like here. Where is it? Extra review, here we go. So there's a mid-semester review worksheet and an answer key. So you could open this up, and if you have a printer, fantastic, you can print it. Otherwise, you can do this on a loose leaf sheet of paper, and then the answer key is right underneath it. I don't know why it's loading right now. I guess my internet is being difficult. But you know, you can go ahead and you can work on that. And also notice I opened up all of our Canvas quizzes from this semester, so you can do those. Here we go. You can do Canvas quizzes for extra practice as well. Okay, if you have any questions, let me know. Have a good day.